Google's Willow Chip, the future of quantum computing. Google has unveiled its latest quantum computing chip, Willow, a major leap in quantum technology. Section 1. What is the Willow chip? Unlike classical computers, which use bits, zeros and ones, quantum computers use qubits, which can exist in multiple states simultaneously due to quantum superposition. The more qubits a processor has and the more stable they are, the more complex problems it can solve exponentially faster than traditional supercomputers. Google's quantum computing journey. Google has been working on quantum computing for over a decade, with key milestones such as 2019, Google's Sycamore processor achieved quantum supremacy, solving a problem in 200 seconds that would take a classical supercomputer 10,000 years. 2023, Google's Bristlecone processor was used in research to explore error correction and noise reduction. 2024, Google introduced Willow, surpassing all previous processors in qubit stability, error correction, and computational efficiency. Technical specifications of Willow qubit count: 105 superconducting qubits, an upgrade from previous processors. Processing speed: can perform calculations in minutes that would take classical computers millions of years. Section 2. Key breakthroughs with Willow 1. Exponential error reduction. Traditional quantum computers struggle with error rates, making long calculations unstable. Willow's new error correction method allows error rates to decrease as qubits increase, a critical milestone in making quantum computing practical. This brings Google closer to building a fault-tolerant quantum computer capable of running complex algorithms reliably. 2. Increased computational power. Quantum processors must operate at temperatures close to absolute zero, Manu 273, to maintain qubit stability. Willow optimizes qubit interactions, making it one of the most efficient quantum chips ever created. 3. Potential for practical applications. Google claims that Willow's performance makes quantum computing feasible for real-world problems, such as drug discovery, simulating molecular interactions to design better medicines, AI and machine learning, training AI models far beyond classical computing capabilities, cryptography and security, breaking and designing ultra-secure encryption methods. Section 3. How does Willow compare to other quantum computers? Google versus IBM. IBM has also been advancing quantum computing with its Eagle and Osprey processors. IBM's latest quantum chip has 127 qubits, but Google's error-correcting mechanism gives Willow an edge. Google versus China's quantum research. China has also invested heavily in quantum computing. In 2020, China's Jiuzhang quantum computer solved a problem in seconds that would take a classical computer 600 million years. Google's Willow chip seeks to take the lead by achieving scalability and commercial feasibility. Section 4. Global impact of Google Willow. After Google's announcement, Alphabet Inc., Google, shares rose as investors saw the potential for quantum computing to disrupt industries. 2. Effects on cybersecurity. Willow's computing power could crack existing encryption methods, forcing governments and corporations to develop quantum-resistant security systems. The U.S. government is already working on post-quantum cryptography to prepare for this shift. 3. Quantum AI synergy. Google's AI research division is exploring how quantum computing could power next-generation AI models. Large-scale machine learning tasks could see exponential improvements, reshaping AI's capabilities in scientific research and automation. Section 5. Expert reactions and industry responses. Tech industry leaders. Many leading scientists and researchers have called Willow a historic leap in quantum technology. Google's AI and quantum teams emphasize that error correction is the final barrier before large-scale quantum adoption. Governments in the US, EU, and China are investing billions into quantum computing, seeing it as a strategic priority for national security and economic growth. Investor sentiment. Venture capital firms are investing in quantum startups, anticipating commercial viability within the next 5 to 10 years. Google's quantum division may soon explore partnerships with financial, pharmaceutical, and aerospace firms to apply Willow in real-world scenarios. Potential challenges for Google Willow. 1. Scalability issue. While Willow improves error correction, scaling from 105 qubits to thousands of qubits is still a challenge. A full-scale, fault-tolerant quantum computer requires millions of qubits, something experts say is still a decade away. 2. High costs. Quantum computers require massive cooling systems, isolated environments, and expensive superconducting materials. Cost-effective quantum solutions remain a major hurdle, before businesses can widely adopt the technology. The future of quantum computing. What's next for Google? Google's long-term goal is quantum advantage, where quantum computers outperform classical supercomputers in practical tasks. Future updates to Willow may include higher qubit counts, better error correction, and expanded real-world applications. The path to commercial quantum computing. Experts predict that by 2030, companies may have hybrid quantum classical systems for specialized tasks. Google, IBM, and startups like Rigetti Computing and D-Wave are actively working to make quantum computing commercially viable. However, challenges like scalability, high costs, and competition remain before quantum computing becomes a mainstream technology. The next decade will determine whether Google's investments in quantum research will lead to widespread adoption and industry transformation. Thank you for watching this in-depth analysis of Google's Willow Chip. Stay informed on the future of technology and quantum computing.